Example 6 says the relationship between the length L in meters and weight W in kilograms of a species of fish in the Pacific Ocean is given by W equals 10.375 L cubed. The rate of growth in length is given by dl dt equals 0.36 minus 0.18 L, where t is measured in years. Part A says determine a formula for the rate of growth in weight, dw dt, in terms of L. So dw dt, if we use chain rule, we will find that that's equal to dw over dl times, since we're given dl dt, that's what we would want to use here. And we can find both of these things. So we're given the w function, so to find dw dl, we would need to take the derivative of that. So if w equals 10.375 L cubed, then dw dl is going to equal 3 times 10.375 L squared, which equals 31.125 L squared. And we're already given dl dt, so we can substitute this stuff in. So dw dt equals, I'll substitute in 31.125 L squared, and then dl dt is given, and that is 0.36 minus 0.18 L. And if we do some multiplication, our final answer should be 11.205 L squared minus 5.6025 L cubed. Part B says if a fish weighs 30 kilograms, approximate its rate of growth in weight using the formula found in Part A. So we know that the fish weighs 30 kilograms, and we have the original function w is equal to 10.375 L cubed. And so we can replace 30 in this equation for w to solve for L. So divide both sides by 10.375. And we would get L cubed is equal to 30 over 10.375. And then we could take the cubed root of both sides and get L is equal to the cubed root of 30 over 10.375. And if you throw that into your calculator, that is approximately 1.4247 meters. Now, we calculated the formula for dw dt in the previous part. And so if we evaluate that for L equals 1.4247, that is going to equal 11.205 times 1.4247 squared minus 5.6025 times 1.4247 cubed. And if you throw that into your calculator, that is approximately 6.542 kilograms per year. So that is the rate of change if a fish weighs 30 kilograms. Example 7 says, find the equation of a line that is tangent to f of x equals the quantity of x plus 1 over x minus 1 cubed at x equals 3. So just like with 90% of these problems, we want to take the derivative first. So let's see, we're going to need to use the power rule and chain rule. So I'm going to bring down the power, and I'm just going to leave that other function on the inside. And then squared. Oh, we're also going to have to use the quotient rule because now I need to multiply this by the derivative of the inside function. And the derivative of that is going to require the quotient rule. So let's see, we have the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is 1 all over the bottom squared. Wow, that is a beast. Okay, so let's simplify that a little bit. We have f prime of x is equal to 3 times x plus 1 over x minus 1 squared times, I'm going to simplify this off to the side over here. So the numerator of this thing is going to be x minus 1, and then if I distribute this in, because the 1's not going to do anything, it's just going to keep it the same. So if I distribute the minus sign in, I get minus x and minus 1. So if I simplify that, that leaves me with negative 2 as my numerator. So this should be negative 2 over x minus 1 squared like that. And then we get f prime of x equals, I'm going to multiply the 3 and the negative 2 together. So that would give me negative 6. And then I could rewrite, if I distribute the squared to both the numerator and the denominator here, that's going to give me x plus 1 squared over x minus 1 squared, and then times 1 over x minus 1 squared. So now I can multiply those, so it's not quite so monstrous. So we get negative 6 times x plus 1 quantity squared over x minus 1 to the 4th power. So there we have found our derivative function. So now what we need to do is we need to find the slope of the tangent line when x equals 3. So we will do that by evaluating our derivative function at x equals 3. So we have negative 6 times 3 plus 1 squared over 3 minus 1 to the 4th power, which gives us negative 6 times 4 squared is 16 over 2 to the 4th power, which is also 16. So the 16s will divide out and give us negative 6. So we found the slope of the tangent line. Now what we need to do is we need to figure out what the ordered pair is that goes through this line. So we know for our ordered pair, the x value is 3. So we have 3, we have the slope is negative 6, and we have the ordered pair is 3 comma something. And the way that we figure out what that something is we plug in 3 into the original function. I have a lot of writing here, so I'm going to section this off. So we want to evaluate f of 3, and that's going to be 3 plus 1 over 3 minus 1, and that is all going to be cubed. So that's going to be 4 over 2 cubed, which is 2 cubed, which equals 8. Okay, so now I can go ahead and we know that our ordered pair is 3 comma 8, and the slope of the tangent line is negative 6. So if I want to use the point slope form, then my line is going to be y minus 8 equals negative 6 times x minus 3. And then if you wanted to change that into slope-intercept form, you can distribute the minus 6. And then add 8 on both sides. So in slope-intercept form, it would be y equals negative 6x plus 26. Example 8 says differentiate using the chain rule, then by using the product rule if f of x equals 1 minus 3x squared. So first let's use chain rule. F prime of x will equal 2 times 1 minus 3x to the first power times the derivative of the inside function, which is negative 3. And if we simplify that, that's going to give us negative 6 times 1 minus 3x, and then we can distribute the negative 6 in to get negative 6 plus 18x. And let's use the product rule now. And if we do that, we want to rewrite this as 1 minus 3x times 1 minus 3x. So f prime of x will equal the first times the derivative of the second plus the second times the derivative of the first. And that equals, I'm going to distribute the negative 3 in, so that's negative 3 plus 9x minus 3 plus 9x, and then if we combine our like terms, we get negative 6 plus 18x. So we can find the derivative using either of those methods.